Good morning, ladies and gentlemen. I will talk about the unit of reactive power. There are three quantities of interest related with measurements of sinusoidal electric power: active power, reactive power, and apparent power. Though they have the same unit expressed in terms of base units, electrical engineers need to compute them separately. Problems have occurred in at least one country when national governments adopt in their legislation only the coherent derived units adopted by the SI. This issue was addressed by the CCM at their meeting held in 2017. For sinusoids, it is convenient to represent the instantaneous values of the voltage and the current as the real parts of complex exponentials, where V and I are complex scalars or phasors. The instantaneous electric power is given by this expression. If we average it over an integer number of signal periods, we obtain this expression, which can be written in a more convenient form using complex notation in this way. The scalar S represents the amount of complex energy per unit time flowing in a given point of a network. It is referred to as the complex power. The magnitude of the complex quantity S is called the apparent power and is expressed in volt-ampere to distinguish from the real part, which is expressed in watts. Consider a network of inductive, capacitive, and resistive elements driven by a voltage source. Expressing V and I in polar coordinates, we obtain the complex power expressed in polar coordinates. The complex power entering the network can be computed as this expression here. Taking the real part and imaginary part, we get this term as the active power and this term as the reactive power. Active power in watts and reactive powers in var. This term, the active power, is related with the power dissipated as heat in the network and also related with the work realized in the facility per unit time. And this term, the reactive power, is proportional to the difference between the time average electric energy and the time average magnetic energy. There is an alternative sign convention. American meters use this convention here and take the voltage as the reference phasor. Here you can see the voltage as the reference phasor and the lagging power factor, where the current lags the voltage. The reactive power is negative for lagging power factor. The time averaged value of the magnetic energy exceeds the time averaged value of the electric energy in the network. In contrast, European meters use this convention, where I is the reference phasor. The current is the reference phasor. You can see here an example of the leading power factor, where the voltage lags the current. The reactive power is negative for leading power factor. Look here, the reactive power is negative for lagging power factor. And the time averaged value of the electric energy exceeds the time average value of magnetic energy in the network for a leading power factor, of course. The reactive power is a measure of the extent to which the source participates in the interplay of stored energy in the facility. It is physically possible for one passive network to supply the reactive power called for in another. National regulations are issued to limit this excess in the average value of magnetic as compared with electric stored energy. With further improvement of power electronics, reactive power compensation is a key method to establish reliable AC power transmission. Let us see the impacts on the MRA. The CIPM MRA is the structure through which NMIs demonstrate the international equivalence of their measurement standards and certificates. It comprises the key comparisons and the NMI and designated institutes calibration and measurement capabilities, the CMCs. There are now 6 regional metrology organizations: the SIM, Euramet, Afrimet, COMET, APMP, and GulfMet. CCM K5 key comparison on electric power that was run from 1996 to 1999 included only measurements of active power. In contrast, SIM key comparison from 2010 to 2012 modified the original protocol by adding test points for reactive power. Though using a traveling standard similar to that used in SIM key comparison, the current CCM K5 key comparison again included only measurements of active power. However, all NMIs and designated institutes who have CMCs published in the Appendix C of the MRA and are capable to perform reactive power measurements list such services in their CMCs and use the unit symbol var when declaring the related CMC entries. The quantity reactive power is relevant for national commerce and economics. National legislations regarding the use of units are in general based on the SI. The specific legislations on units are elaborated based on international standards, which ultimately follow the SI brochure. The IC standard 8000-6 is adopted as a reference in the specific case of electrical units. These standards regard the volt-ampere as the coherent derived unit of reactive power, and the var as a non-SI unit accepted by IC for use with the SI. It assumes that both units are on an equal footing. Problems have occurred in at least one country when national governments adopt in their legislation only the coherent derived units listed in the SI brochure. Electrical utilities and instrument manufacturers refuse to adopt the volt-ampere for the unit of reactive power. One could think that the problem could be solved by IEC, but this would mean to change the arrangement of units adopted for that standard, and that arrangement is correct and follows the SI brochure. This issue was addressed by the Consultative Committee on Electricity and Magnetism, CCM, in March 2017. CCM decided to submit to the Consultative Committee on Units, CCU, a proposal to add a side note on the VAR to the 9th edition of the SI brochure. And this side note here was approved to be included in the 9th edition of the SI brochure. The International Electrotechnical Commission has introduced the VAR, symbol VAR, as a special name for a unit of reactive power. In terms of SI coherent units, the VAR is identical to the volt-ampere. Conclusions. The quantities active power, reactive power, and apparent power should have different unit names and symbols to emphasize the different nature of the quantities concerned. The measurement of each of these quantities and the correct interpretation of their meaning are relevant for the society. They have played a significant role in the last century since the advent of electricity, and this is expected to continue in the future in the realm of smart grids. The VAR is now mentioned for the first time in the SI brochure, so that it may be directly adopted in national legislations as the unit of reactive power. We acknowledge the following individuals for their help in the definition of the side note. Thank you very much.